Welcome to CHSG Science lesson. In this video, we will be revising P2, which is about energy transfer by heating. Here is a bigger picture of all the topics. So by the end of this video, you should be able to learn about compare the thermal conductivities of materials and relate to uses. You should also be able to describe the behavior of particles in material as temperature increases. And finally, you should be able to explain the specific heat capacity of different materials. So first of all, we will learn about conduction. Conduction is a process of transferring heat energy. How did the energy move along the rod? As we know, the rod is made out of some particles, and all the particles in solids are close to each other, but they are always vibrating on their own position. When you start heating the rod, the heat transfer from one particle to the other particle, and the particles get more energy and vibrate more. Particles also bump into each other, and by bumping into each other and due to their vibration, they pass their heat energy along. So due to the vibration and particles moving around, the heat energy is transferred. So the thermal energy is passed through the rod as the particle bumps into each other. The entire rod eventually heats up, and this is called conduction. So you can pause this video and try to fill in the blanks. You can discuss with your partners, use the words. Welcome back. So we can try together. When we heated the metal rod, the particles received more energy. This meant they vibrate more and bumped into each other. As they bumped into each other, they passed on some of their energy. This means the heat or thermal energy moved through the rod. Eventually, the rod heated up. We could see the rod got hotter as the Vaseline melted. This method, the drawing pins fall off. The movement of thermal energy like this is called conduction. Well done if your all answers were correct. This is the example of house. This picture has been taken from the infrared camera, which determines the heat energy releasing out of the house. So in this picture, discuss with your partners which areas of this house have the best and worst insulation. You can pause the video and discuss with your partners. Well done. A poorly insulated house loses more energy and so costs more to heat. It also means that more pollution, particularly carbon dioxide, is created in order to heat the house. So in infrared camera, the brighter the color means more hot it is. So where it is more hotter, it is releasing more energy, and it means this is poorly insulated. This is another example of the house with energy percentage efficiency loss. So 8,000 joule of energy lost in total per year. 25% energy lost from roof, 35% energy lost from the wall, 15% to the ground, 15% from the door, and 10% of energy losses from the windows. So what keeps our homes warm? So insulation is the best solution to keep heat inside. So you can discuss with your partners what ways of keeping a home warm are there. So you can pause this video and come up as many solutions you can. Brilliant, well done. So there are some solutions and ways of keeping a home warm are there. loft insulation, cavity wall insulation, pipe lagging, boiler insulation, double glazing windows, thicker bricks, putting an aluminium foil panel behind radiators. So payback time is very important terms when we want to do some improvements in our house to save energy. So doing these improvements, there will be some affordable, there will be something that some people can afford it and some people cannot, or some people need to know that how much it would be beneficial for them and what should we do. So payback time calculation will be helpful for them to think about the improvements. So if cavity wall insulation cost is £500, so it will save £100 every year. So to calculate the payback time, these two things we need to learn. One thing, how much cost, and the second thing, how much saving per year would be. Similarly, if drought excluders need £30 cost and it will save £20 every year, and double glazed windows cost £3,000, but it will save £100 every year. That's the equation for calculation of payback time. Cost divided by saving per year. Each method has a different cost and saving, so we can calculate the payback time by using this equation. If savings are bigger than the cost, then the method is cost effective and worth doing. So use this equation and calculate your payback time and discuss with your partner that this improvement is worth to do that, is that cost affecting or not. So you can pause this video and come up with your answers. Welcome back. Now, next thing here, we need to learn about the specific heat capacity of different material. Before that, I want you to discuss with your partners which kettle boils first and why. Well done if you think the kettle with less water, and the reason behind it, because the kettle with the less water has less particles to absorb heat. So that's why the kettle with the less water will boil first, because it needs less energy for the particles, because there are less amount of particles. So the concept of specific heat capacity is when in a sunny day, the sun is providing heat both at the same time, water and sand, but the temperature of water and sand are different from each other. So this is because of the different materials. So each material, each particle has different capacity to absorb heat. So this is what called the specific heat capacity. If consider this in more detail, so we can see the sun is providing heat at the same time water and sand. Same amount of energy is absorbed by both water and sand, but the temperature rise for both is different. Sand is much hotter than water. So there is a small temperature rise in water and there is a large temperature rise for sand. Putting the same amount of heat into the same material gives the bigger temperature rise than in other materials. So this is due to have different specific heat capacity of different materials. So each material has different heat capacity, has different capability to absorb heat. If we give the proper definition, so when we talk about the specific, then we need to talk about the specific temperature and specific mass. So specific heat capacity is the amount of energy needed to raise the temperature of 1 kilogram mass by 1 degree Celsius temperature. So here is the equation of a specific heat capacity. So in short, heat equals mass times specific heat capacity times temperature change. Now, using that equation, can you calculate the specific heat capacity for these questions? Consider the specific heat capacity of for all question is 1000 joules per kilogram centigrade degree Celsius, and you can pause this video and come up with your answers. Welcome back. Now you can mark your answers. Well done if you got all answers correct. If not, you can try again those questions. Here are some exam questions about how to calculate the specific heat capacity. For each questions, there is different temperature rise and different specific heat capacity. So you can pause this video for next 5 minutes and try to come up with your answers. Well done if you got the answers. Now let's check your answer. Brilliant if you got all answers correct. If not, you can try again. So I hope you have learned in this video. Now good luck for your exam preparation.